We think about diet and exercise, but we almost never think about the light diet our cells are consuming. Today, we're breaking down a fascinating conversation between Dr. Andrew Huberman and Dr. Glen Jeffery, a professor of neuroscience at UCL. They discuss a terrifying reality about modern LED lighting and a simple, almost magical solution involving red light that can heal your vision, lower blood sugar, and recharge your mitochondria. How serious is the problem? Dr. Jeffery makes a claim that will stop you in your tracks.
This is an issue on the same level as asbestos. This is a public health issue and it's big. And I think it's one of the reasons why I'm really happy to come here and talk, because it's time to talk. When we use LEDs...
Since around 2005, we've replaced almost all our incandescent bulbs with LEDs. They save energy, but they might be costing us our health. Dr. Jeffery explains that while LEDs look white, they are actually spiking with high-energy blue light and completely lacking the healing red wavelengths we evolved with.
Found in LEDs, when we use them, certainly when we use them on the retina looking at mice, we can watch the mitochondria gently go downhill. They're far less responsive. Their membrane potentials are coming down. The mitochondria are not breathing very well. You can watch that in real time.
Under LED light.
Think of your mitochondria as batteries. Under LED lights, they slowly lose their charge. But how does red light actually fix this? For years, scientists were stumped. It turns out, the answer was much simpler, and stranger. It has to do with the water inside you.
Which we have to take quite seriously, is that the viscosity of water is changing as a consequence of long wavelength light that penetrates deeply in the body. There is an increase in the spin rate of the motor that produces ATP, and it gains momentum. Now, that is absolutely fine. I can stick with that one. I think that...
This is mind-blowing. The red light changes the physical properties of the water surrounding your mitochondria, making it less viscous. So if your batteries run better, what happens to your metabolism? In a groundbreaking experiment, Dr. Jeffery's team shone red light on people's backs, nowhere near their eyes, and measured how their bodies processed sugar.
People, a burst of red light beforehand to stimulate their mitochondria was super clear. It wasn't ambiguous. The blood glucose levels went up, but they didn't peak anywhere near as seriously as they did without the red light. Now, I'm told that the level of your blood glucose is not necessarily a massive issue for concern.
By illuminating just a small patch of skin on the back, they reduced blood sugar spikes by 20%. You might be thinking, does light really get inside me? We assume skin and bone block light, but long wavelength red light is different. It's like a ghost, it passes right through walls.
He takes the neonate and actually does exactly that experiment. He passes red light, wavelengths of light, through the side of the neonate's head and records them coming out the other side. And he can use that as a metric of how well the mitochondria are functioning in that damaged brain. And the readouts that he gets are readouts that are indicative of the potential survival of that neonate.
Wow.
Now, I think there are lots.
It travels through the skull. This is why red light therapy is being investigated for brain health. One of Dr. Jeffery's most famous findings involves vision. As we age, our retinal cells die off. But he discovered that a specific dose of deep red light could reboot the aging eye. And the craziest part? You don't need to do it for hours.
Days. And the real big point to take on board is it's a switch. There's not a dose-response curve here. It is you put enough energy in at a certain wavelength of light and it goes bang and click. And then 5 days later, it goes chunk and stops.
Just one single exposure of about 3 minutes kept vision improved for 5 whole days. If red light is so good, why are we so sick? It's our architecture. We seal ourselves in boxes that do two things. They bombard us with isolated blue light from LEDs, and they block the natural infrared from the sun.
All commercial buildings and all big buildings now, not domestic ones, will invariably have infrared blocking glass. So you get the first hit on the fact that your LEDs are pretty awful, undermining your mitochondria. The second is you're isolated from the visual world outside by the infrared blocking glass. This is a double hit, and I think that double hit is quite significant. Now we
are starving for red light. So, do you need an expensive medical device? Not necessarily. Dr. Jeffery shares his own morning routine, which involves a piece of technology you might have thrown away 10 years ago.
You're spending that 45 minutes that really should be 10 minutes, but you're faffing around doing stuff. There's a halogen lamp there on at the right time. It's not desperately bright, but it's there at a critical time during the day.
What color does it appear?
Ordinary white.
A simple halogen or incandescent bulb produces a full spectrum of light, including that vital infrared. This conversation fundamentally changes how we view our environment. Light is food for your cells. Malnutrition isn't just about food, it's about missing wavelengths. Get outside, or bring the sun inside with full-spectrum incandescent bulbs. If you found this summary helpful, hit the like button and subscribe.